In lesson 2.9, we're talking about general solutions and principal values of sine and cosine. So if you were to type into your calculator inverse sine of 0.5 and do that in degrees, what it's asking is what is the angle whose sine is 0.5, because you're doing the inverse, so you're asking for an angle. So if I type this in and I'm in degrees, so inverse sine of 0.5, I get 30. I get 30 degrees. Now 30 is called the principal value. This is given by the calculator. It has to fall within the range. And it's the first time you see it in the unit circle, but I'll explain that later. First time in your unit circle. So I've got calculator, value of 30, and it falls within the range. So sine's range I have in the table here is between negative 90 and positive 90, and 30 is between negative 90 and positive 90. So that's what I mean by falling within the range. Now, sine of 30 is not the only thing that gives you 0.5. If I type in, so sine 30, we can see you get 0.5, 1/2. But if I type in sine 150, I also get 1/2. So 30 is not the only answer, but it is the only principal value. So that's why it has a special name of principal value. What if we do negative 1/2? So negative 1/2. I get negative 30. So again, that falls within the range. It's between negative 90 and positive 90. So that is what we're getting here. Now, negative 30 is not the only thing that'll give me negative 1/2. So here we can test negative 30, and we get negative 1/2, like we said. But what if I did 210? If I put 210 in there, I also get negative 1/2. So 210 is another answer, but it's not a principal value, because 210 is not between negative 90 and 90, even though it gives us the same answer as negative 1/2. So I've got 30 and negative 30 were the principal values. So what if I want more than the principal value, like we were talking about here with the 210? What if I want all of the answers, all the possibilities? Well, that's called a general solution. So if I look for inverse sine of positive 0.5 and I get 30, then I would say that my answer is, theta is 30. But I can find all my coterminal angles to 30, and they also should give me 1/2. So for example, if I add 360 to 30, and I get 390, that also should give me positive 1/2. So 30 plus 360 also works, and I can keep adding 360 and still get values of 1/2. So we're going to put 360 in. So that is a general solution for all of the sine values that will give you positive 1/2. So sine of 30 works, sine of 390 works, and you can keep adding 360 and still get 1/2 as the answer. But we just saw earlier 150 is also an answer. So 150 is also an answer, and we can also add 360 to those. And those should be the only possibilities that we find. And if you notice, this is quadrant 1 and this is quadrant 2, because sine is positive, and sine is only positive in quadrants 1 and 2. And so 30 came from quadrant 1, 150 came from quadrant 2, and that's why there's only 2 answers, because we're not going to find anything in quadrant 3 and quadrant 4 that's going to give us a positive sine value. So those are the general solutions for sine. Principal value is going to have a capital S when it asks for it, capital S, and then lowercase for the general solution. So that's how you can kind of tell the difference. So that's sine. Let's move on and talk about cosine. So cosine of positive 0.5, if I type that in, inverse cosine of positive 0.5, it gives me 60 degrees. So that is, again, the principal value. And it's a capital C, so that's how I know they want the principal value. It falls within the range. So cosine of 60, the range for cosine is 0 to 180, so it's different from the sine. But 60 does fall between those numbers. Now we know cosine of 300 should also give us positive 0.5, which you can see right here. So 300 is another answer, but 300 is not the principal value because 300 is bigger than 180. Let's look at inverse cosine of negative 0.5. And we get 120. We get 120. So 120 is between 0 and 180, so that's why it's in the range. But it's not the only answer for negative 1/2. If we put in 240, we also get negative 1/2, but 240 is outside the range. So 240 is not the principal value, 120 is. So those are your principal values for cosine. But what if we want all the solutions for positive 0.5? What if 60 is not enough? So we're looking for where is cosine positive. That's totally wrong. All students take calculus. So this is a positive answer. So I'm looking for cosine being positive in quadrants 1 and 4. So 60 is the answer that we get in quadrant 4, plus 360 in. And then our 60-degree reference in quadrant 4 is 300. So you can write it like this. But 300 you can rewrite as negative 60 because 300 is just 60 degrees away from 360. So instead of writing two equations, we can write it as 1 plus or minus 60 plus 360 in, which is usually easier to solve for if you write it like that instead of two different numbers. So my principal value will have a capital cosine. My general solution will have a lowercase cosine. Example 1, find inverse cosine of negative 0.3. It's lowercase and it says all values, so they want general solution. So you would type in inverse cosine and you get 107. So this would be 107.4576. And for cosine, you can just do plus or minus 107.4576 plus 360 in, and that is your answer. So if you want to check your quadrants, you don't have to, but if you want to think about it, this was a negative number for cosine, so we were looking in quadrants 2 and 3, and 107 would definitely be in quadrant 2, and negative 107, if you rotate backwards, would definitely be in quadrant 3. So that's why we have positive 107 and negative 107. Now they want us to take this general solution in example 2 and find the first three positive values of cosine. That gives us negative 0.3. So I usually make a chart of these. So starting with 107, and then I'm going to add 360 to that. And then over here, start with negative 107 and add 360 to that. And we're looking for positive answers. So if I subtract 360, it'd be negative, so don't do that. If I leave it alone and I don't add 360, it's positive. So that's one of them. If I add 360 to this, I get 467. If I add 360 again, I get 827. So that's enough for that list. Over here, if I subtract 360, it'll be negative, and I don't want that. If I don't add 360 at all and leave it alone, it'll be negative, and I don't want that. So I have to add 360 to begin in this list. So you take that number and add 360 to it, and it turns positive. It turns into 252.5424. Add 360 to that, you get 612. And if you look at your list, you have a bunch of positive answers now. And they want the first three, so the smallest three. The smallest positive I see is this one, so that's my first answer. The next smallest is 252, that's my second answer. And then the third smallest is the 400, that is my third answer. So that's what they want in example 2. Example 3, new problem, we're in radians now because they have an x. So you're going to go to whatever your calculator does to change the mode, change it into radians, and type in inverse cosine of 0.427. And I'm getting 1.1296. I'm going to put plus or minus on that because it's cosine. And instead of adding 360, I'm going to add plus 2 pi in, because we're in radians. 2 pi is the same as 360 in radian form. So this is the general solution, but they want the first 3 positive values, so we're going to make that chart that we just did on the last problem. So I'm going to start with 1.1296 and add 2 pi to those. And then I'm going to take negative 1.1296 and add 2 pi to those. If I subtract 2 pi, it'll be negative, so I don't want to do that. If I leave it alone, it's already positive, so leave it alone. If I add 2 pi, I get 7.4128. If I add 2 pi again, I get 13.696. Over here, if I subtract, it'll be negative. If I leave it alone, it'll be negative. So I have to start off by adding. So add 2 pi. You get 5.1536. Add 2 pi again. 11.4368. And we can already see that I've got 3 positive answers. This is my first positive. This is my second positive. And this is my third positive. So those are the answers they are looking for. In example 4, we've got sine, and we're in radians because there's an x. So change your calculator to radians if you didn't before, and type in inverse sine of 0.67. And I'm getting 0.7342. And sine, you do not do plus or minus like we had before. So it'll be positive 0.7342 plus 2 pi n. And to get the other value of sine, you always want to do 180 minus that. So, or not 180 since we're in radians, but in this case, pi minus that. So pi minus that would be 2.4074, and that is my other equation. So why did we do that? We're looking at a positive answer. All students take calculus. All students take calculus. So we got a positive answer, and the first thing we get is going to be in quadrant 1. That's where that one's from. And this is kind of your reference angle. So I know my other positive answer is going to be in quadrant 2. The closest thing to quadrant 2, the closest x, is 180. And so you're always taking the answer you got in quadrant 1 and subtracting it from 180 to put it in quadrant 2. So that's how you're always going to get those two answers. When you look at a unit circle for negative rad 2 over 2, you're looking for a, well, this is asking for a general solution because it says all values in sine. So we're going to look in our unit circle, so get that out. So the question asks us, where is sine negative radical 2 over 2? So remember, sine is the y values. So we see it's positive radical 2 over 2 in these quadrants. Here, sine is negative radical 2 over 2, which is 5 pi over 4. And here, sine is negative radical 2 over 2, which is 7 pi over 4. And so those will be our answers, 5 pi over 4 and 7 pi over 4. Let's go back. You write it like this and this. If you wanted just the principal value, you would have to look back at your unit circle. And the range for sine is negative pi over 2 to positive pi over 2. So this one is too big. It's bigger than pi over 2 in both directions. But your 7 pi over 4 you can write as negative pi over 4. And so that's how you would write it as a principal value.